A particle is moving at velocity 8 meters per second and acceleration 4 meters per second squared from a point P. 3 seconds later, a second particle moves from the same point P with a speed of 12 meters per second and acceleration of 8 meters per second squared. Calculate the time when the second particle overtakes the first particle and calculate the displacement from P at this time. Now, if we look at this using this GeoGebra app, and I'll put the GeoGebra app in the notes of the video. Okay, so here we've got the first particle and the time is equal to 0. If we start the animation, okay, the first particle goes off and then the second particle will start at 3, and there will be a time where they over P2 will overtake P1, and that actually is at when t is equal to 10 seconds, and when it's 280 meters from P, we can see that P2 and P1 will be at the same position. Now, if we scroll back to when t is 0, we only get the first particle, but the interesting thing is when t is equal to 3, which is there, okay, the second particle will appear. And why it is 0 here is because if you put t minus 3 instead of t, and the great temptation is to put t plus 3, but it's t minus 3, okay, then if you put 3 into that, you can see that will be 0, that will be 0, and then the whole thing will be 0. So if it's 3 seconds later, then it's going to be t minus 3, not plus 3. Okay, so now I'm going to do the maths to come up with the answers that I've just shown you. So for particle 1, using s is equal to ut plus a half at squared, we had u is 8 and a is 4, so s will be 8t, s1 will be 8t plus a half times 4 times t squared, and that comes down to 8t plus 2t squared. We'll call that equation 1. For the second particle, as previously explained, s2 will be 12 times t minus 3 plus a half times 8t minus 3 squared, and why it's t minus 3 is when t is 3, we want the displacement to be 0, so that will ensure that the displacement is 0 when t is equal to 3. So it's t minus 3, not t plus 3. Simplifying that, we're going to have 12 times t minus 3 plus 4 times t minus 3 squared. We'll call that equation 2. At time when P2 overtakes P1, then S1 will be equal to S2. So we're going to take S2, which is that, 12t minus 3 plus 4t minus 3 squared, and put it to 8t plus 2t squared. Expanding the bracket here, we're going to have 12t minus 36. Now do this bit at a time, plus 4. Now t minus 3 squared is t squared minus 6t plus 9 is equal to 8t plus 2t squared. And now passing through the 4, so we've got 12t minus 36t, sorry, minus 36, sorry, plus 4t squared minus 24t plus 36 is equal to 8t plus 2t squared. Now, the 36's will cancel out, and you're going to have 4t minus 2t, which is going to give you 2t, and then you're going to have 12t minus 24t minus 8t, which is minus 20t, is equal to 0. Common factor there of 2t, so you've got 2t brackets t minus 10 is equal to 0. Going ahead and solving that, 2t, t minus 10, either t is equal to 0 or t is equal to 10 seconds. Now, how do we explain this one? Well, for them to overtake, the second particle doesn't actually appear until t is greater or equal to 3. So we can say that one's not possible, and therefore t was equal to 10 seconds, like in the GeoGebra app. So when t is equal to 10 seconds, using equation 1, we'll just substitute that in because it's the easier of the two. S is going to be 8 times 10 plus 2 times 10 squared, which is equal to 80 plus 200, which gives 280 meters from P. So if we go back and look at this again, and then we slide the time to 10 seconds, it's quite hard to actually get 10 seconds. Which is there, we can see that these are equal at 10 seconds, and that the distance from P, or displacement from P, will be 280 in both cases. Okay, this has been a video to show you, to find the time when one particle overtakes another particle and how far it is from the starting position. I hope you've understood, and I thank you very much for watching.